plane geometry, which is angles and intercepts of angles in a parallel line. First of all, what is an angle? An angle is simply the space between two lines. Once we have two lines that meet at a point, the space between the two lines is referred to as angle. If this is line AB and also line AC, the space between line AB and line AC is referred to as angle. Also, we can also refer to as angle as the arc or the curve formed when two lines meet. So for two lines to meet, it means they must share the same vertex. They must share the same origin. So let's go to types of angles. First of all, we have right angle. What is a right angle? A right angle is simply an angle that is of 90 degrees. A 90-degree angle is referred to as a right angle, which is if we have line AB and from line A we have a perpendicular line AC, so we call this a right angle. Also, we also have acute angle. What is an acute angle? An acute angle is simply an angle lower than 90-degree angle. So assuming we have a right angle, this is a right angle. An acute angle is the angle that is lower than a right angle. This is an angle lower than 90 degrees. So our acute angle will be from any point on the ground to there. So long it does not get to the 90-degree angle, it shouldn't get to 90-degree angle, is referred to as acute angle, which is diagrammatically, this is what an acute angle looks like. Acute angle, an angle lower than 90 degrees. It shouldn't get to the right angle. Also, we also have what is known as obtuse angle. An obtuse angle is an angle that is greater than 90 degrees. So peradventure we have a 90-degree angle. This is a 90-degree angle. Obtuse angle is an angle greater than 90 degrees. It is an angle that's greater than a right angle. So for our angle to be greater than 90 degrees, from the ground floor here, it should crosses over 90 degrees and stop before 180. So we call this an obtuse angle. Diagrammatically, this is what an obtuse angle looks like. From the floor, this is a 90 degree, it should crosses over 90 degrees. We call it an obtuse angle. We also have what is known as a reflex angle. A reflex angle is simply an angle that is greater than 180 but less than 360. So, peradventure we have and obtuse angle. So the reflex angle from this obtuse angle is the angle greater than 180 but less than 360. This is our reflex angle, and this is an obtuse angle. We can also have a reflex angle from an acute angle. If this is an acute angle, which is less than 90 degrees, the reflex angle here is the other point. Now we have also adjacent angles. We can say an angle is adjacent. What is adjacent angles? Adjacent angles are simply angles that share the same vertex. When we have two or more angles that share the same base or the same vertex, for instance, assuming we have angle theta here and also angle beta here, angle theta and angle beta, they are adjacent angle. Why? Because they share the same vertex, so they are adjacent to each other. They are adjacent angle. Also, we have what is known as vertically opposite angle. Angle is said to be vertically opposite angle only when it meets this criteria. If we have a straight line angle and also we have a line cutting the straight line, if this is angle A, this is B, this is C, and this is D. Now, angle D is vertically opposite B, and also A is vertically opposite C. So long we have two straight lines that cut each other, straight lines, the angle formed that is opposite, we refer to the angle as vertically opposite angle. We also have alternate angle. However, in alternate angle, we must be dealing with two parallel lines. Whenever we have two parallel lines that is cut by a transversal line, let's say this line is parallel to this line, and this line here is a transversal line. Let's say line AB and line CD. They are both parallel and cut by a transversal line. The angle formed here is alternate to the angle here. This angle is alternate to this. If this is angle E and this is F, E is alternate to F. The same thing applicable if this is G, G is what? Alternate to H. Also, we can look at alternate angle in a different dimension. This is a parallel line. Also, we have a parallel line. Let's call these two lines parallel. And we have a transversal line. Let's call it a transversal line. So angle ABCD EFGH. So for us to get the alternate angle formed here, we look at the Z shape that is formed. Any Z shape that is formed, either the Z shape facing this direction or the Z shape facing this direction, is referred to as alternate angle. The interior angle here versus the interior angle here. The interior angle versus the interior angle here, we call them alternate angles. And alternate angles are equal. Now, for this, we look at this using the Z shape on this. We have our Z shape, so which is this angle and this angle, which is D is alternate to E. D is alternate to E. Now, looking at this shape, which is this, and this, we have F and C. F is alternate to C. So this is how to get alternate angle. And every alternate angle are said to be equal. Now let's check corresponding angle. Corresponding angle is also an angle gotten from two parallel lines. For you to get a corresponding angle, you must be dealing with two parallel lines that is cut by a transversal line. However, corresponding angles are said to be equal. Now, to get the corresponding angle here, let's call this AB, CD, EF. Line AB and CD. So to get the corresponding angle, let's compare this. Let's assume this is a replicate of this shape. Now, A is corresponding to C. A is corresponding to C. A and C, they are corresponding angle. Why? If this is our transversal line, cutting two parallel lines. Now, if you look at A is formed on the left. A is formed on the top left of line AB, just like C is formed on the top left of line CD. A is formed on top left of line AB. C is formed on top left on line CD. So A is parallel to C. Also, let's compare B and D. Yes, B is formed on the top right of line AB, and D is also formed on the top right of line CD. So B is parallel to D. So whatever our angle is for B is the same value we'll have as D. Now let's compare EF, let's say GH. G and E. The down left and also the down left. G and E. G and E. On line AB, G is the down left. On line CD, E is the down left. So E is said to be parallel to G. That makes E to be equal to G. The same thing, H and F. Let's consider down right, which is H, and also down right, which is F. From two parallel lines, this is the down right, and this is also the down right. So H is the down right of AB, just like F is the down right of CD. So H is said to be parallel to F, which is H is equal to F. However, we can also use this image to describe vertically opposite angles. We can also use it to describe vertically opposite angles by saying G is vertically opposite B, and A is vertically opposite H, C is vertically opposite F, and E is vertically opposite D. Now, we can't say F is vertically opposite A. No, it is wrong. F is not vertically opposite A. But we can say F is alternate to A using the alternate angle. F is alternate to A, so A is equal to F. We can also say E is alternate to B, which is E is equal to B. But vertically opposite, E is vertically opposite D, which means in vertically opposite angles, we only describe angles vertically using vertically opposite angles for angles that are in a straight line, a single line angle. When we have a single line angle, A, B, C, D. A is vertically opposite D, B is vertically opposite C. We can use two separate parallel lines and say they are vertically opposite. We can only use the alternate angles for such. So let's look at complementary angle. Angles are said to be complementary if they sum up to give us 90 degrees. If we sum up angles to get 90 degrees, we say the angles are complementary. For instance, if we have this shape, which is a right angle shape, and we have adjacent angles formed from this right angle, let's say A, B, and C. All these angles are said to be adjacent angles because they have the same vertex, the same origin. They all meet at this point. So this angle is said to be complementary if A plus B plus C is equal to 90 degrees, which is if we sum up the angles in this right angle and it gives us 90 degrees, we say they are complementary angles. All complementary angles sum up to give us 90 degrees. Now let's check supplementary angles. Supplementary angles are angles that sums up to give us 180 degrees. And this angle, unlike the complementary angle that is gotten from a right angle, supplementary angle will be gotten from a straight line angle. A straight line angle. If we have straight line AB, let's say this is our point on the straight line, and we have adjacent angle formed from this point also. It's angles with the same base, as many as possible. Now, because all this angle has one adjacent and it is formed from straight line, let's say this is A, this is angle B, this is angle C, this is angle D, and this is angle E. So once we sum up A plus B plus C plus D, it is equal to 180 degrees, which is the sum of all the angles formed in a straight line is equal to 180 degrees. We can also refer to this as a supplementary angle, which is angle that sums up to give us 180 degrees. And they are gotten from what? From a straight line that has angles that are adjacent to each other. Now let's look at sum of angle at a point. or the sum of angle in a circle. Now let's compare an acute angle that has a reflex angle attached to it. So if this is a reflex angle and we have interior, we have an acute angle. Let's say an acute angle A, reflex angle B. Now if you look at the both of them, A and B gives us a circle. It forms a circle. Therefore, it means that A plus B is equal to circle, and hence the sum of angle in a circle is equal to 360 degrees. Whenever we sum up A plus B, we get 360 degrees. So the sum of angle in a circle is 360 degrees. The same thing applicable to angles at a point. Angles at a point sums up to give us 360 degrees. Now let's look at interior opposite angles. If we have two parallel lines, line A, B, C, D, that is cut by a transversal line. Don't forget this line that cuts AB is a transversal line. And we have A, B, C, D, E, F, G, H. Now, the opposite interior angles, which is CE, C and E, they are opposite interior angles. D and F, they are also opposite interior angles. Now this rule says the opposite interior angles are supplementary, which is the sum up to give us what? The sum up to give us 180 degrees. The opposite interior angles are supplementary, which is C plus E is equal to 180, D plus F is also equal to 180 degrees.